Good afternoon. I'm Steve Elliott. I'm going to be... Can everyone hear me? Cool. Don't know, can't hear myself. I'm going to be talking about how I believe we should be measuring everything, not just in production. Who am I? I've been a developer for over 10 years. I more recently became a member of the out-of-hours support team, so I kind of crossed the line into having to deal with my stuff out of hours as well, which brought with it a wonderful new understanding of monitoring, logging, keeping your system up, caring about production, really. And then I moved into what we call our I/O team, which is kind of keeping this stuff alive and providing developers a platform that they can build upon. And because I was doing more ops, people started calling me DevOps, which I disliked. So then they started calling me head of DevOps, which I disliked more. I think they were trying to wind me up. And overall, I just call myself a logging enthusiast these days. I love logs. That's probably going to come across. And I do all these things at laterooms.com. We sell hotel rooms. That's Faulty Tales. I don't think it's on the books. Maybe it should be. We've been around 10 years. I think we were one of the first OTAs. But what I really enjoy about Late Rooms is we're quite a forward-thinking company in terms of technology. We're quite involved in the community, that sort of thing. And we've been doing pipelines and the like for about 5 years now. We use Go, continuous deployment, that kind of thing. So 4 work people in the room. We find it's really good. But it wasn't all wonderful. In production, things weren't great. As I say, a few years ago, I was on the front-end website team, and things would go wrong, what I call the dark times. You would come in the morning, and it would be, oh, yeah, site we're down. Oh, right, great. How did we find out? Oh, the CEO phoned up. Not good. So there was no monitoring. All the logs were on separate systems. We had little alerting. What did come through. It was kind of like, is that real? Is it not? Oh, wait, no, it's a board member, and they're annoyed. It was kind of like flying a plane with no instrumentation, with your head out the window, trying to work out navigate a storm. It didn't go particularly well, as you might imagine. So my team, we started a project. Late Rooms has a bit of a history with badgers, so we call it Project Badger, which will explain, hopefully, some of the mild fixation on the animal throughout the slides. We set up a project. We wanted to identify tools that could help us in live solve some of these problems. We did log aggregation using Elasticstack. That was brilliant. Love logs now. We displayed this information all over the place. So we used Kibana, Grafana. We've got a custom application that we called Badger. And we alerted on it as well. And things were better. By the end of the project, it really felt like we turned a corner and we knew what was going on live. People knew things had gone wrong. We could jump on it. It was great. And it felt like you were kind of in a high-tech mission control center from the future, which is great. You had information. Meanwhile, in dev test, things were not so good. We had some challenges. I don't know, so hopefully some of these will be familiar to some people. I know there's been in a couple of places I've spoken to people who have similar issues. The dev test environment didn't have the best in investment. It was slow, or at least people thought it was. There were flaky tests. Often the pattern would go red, 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 green. Deploy quickly before the red comes back. And there was difficulty spotting trends. As a side effect of some of the problems, especially the slowness, we'd started to encourage and allow different dev teams to start to expand the tool set that they used. So one of the first people to jump on this bandwagon were the Node teams. We just started using Node.js. They were wanting to get down to time to live, which we couldn't support in our current system. So they found a system called Circle CI. They did all their building, unit tests in that, and then they came back to the old system to do deploys and other tests in the staging environment we shouldn't have. And that was really good. And then another team saw that. They used .NET, and they thought, that's really cool. They're going faster. I want to do that too. And they found AppVeyor. And now we had Circle CI, AppVeyor. Because we'd opened the floodgates, another team decided they wanted to use TeamCity, and then another team decided they wanted their own Go server because they were in AWS, and so on and so forth. And suddenly there were 5 or 6 CI systems, lots of dev test environments, and it was getting really difficult to keep track of what was going on. Slowness was a big factor. As I say, it's what drove a lot of the teams to try and start finding their own tool sets. But it was a sense. No one could really be very specific about it. You know, there was a sense that something is slow. It's not very quantitative. We've been trying to kind of encourage when features come in to get some idea of what benefit they're going to bring. So it isn't just push this widget out. It's kind of like push this widget out and we expect to see this kind of benefit. Kind of like maybe entering into hypothesis testing. That would be brilliant. So what we didn't really want to do is then turn around to the business and go, oh yeah, CI is really slow. How slow? Really slow. Because it's not very quantitative. We wanted to be able to be specific about it and use numbers and science. So as a quick aside, before I get into what we did to try and solve some of these problems, as I say, we did really well in production, and it's kind of ancillarily connected. We've got a dev test environment of the monitoring, and it's been really, really good in terms of people get used to using it. So the devs and the QAs and everyone really, they get used to the information being available in dev test. If something goes wrong when they deploy onto a QA or CI server, they use the logs instead of trying to go jump onto servers and debug it on that kind of angle. And it's the behavior that starts to drive it out, because now you've got ops people using the same tooling as the devs, and that's really, really valuable. And it's kind of driven some of our teams to some interesting things. So they're starting to make their applications a lot more friendly to logging, because they now see the value a lot more. Because you know, they should care about production. Some of them do. Some of them are more insulated from it. But using the tooling means that they are more aware of logging regardless, and metrics and all those kind of nice things. One of the teams developed this tool they called it Ossilog, because of like ocelots, but with more logs. And that's been really good. It's kind of given a renewed focus on it. And it was part of the thing that kind of triggered in my mind, can we start to use some of these concepts to start to work out what's going in dev test using what we learned in live. So where do you start? Much like with live, we decided we'll start with what do we want to measure. All the things, but we tried to be a bit more specific about it. As I say, slowness was one of the bugbears of developers everywhere. So we wanted to measure, one of the critical metrics was between the time it takes me to commit and the time it takes my tests to kick off, or my build to kick off. How long is that? The CI system, Go, provides quite a few metrics, but it didn't give that metric. So we wanted to try and measure that. How long are my tests taking? Again, Go does deliver that, but it's all over the place. We wanted to aggregate this in all one place. And how flaky are my tests? So is it going red, green, red, green, red, 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 green, deploy? The thing is, this is probably going to be specific to what you're doing. So if you're trying to get metrics out of your dev test, just like in live, you're going to want to generate your own list. So we know what we wanted to measure. The next step is then trying to measure it. Where do you start with that? Logs. I really, really love logs. But logs, are they like web logs, error logs, that kind of thing? A log can be any kind of timestamp and some information that goes alongside it. So, you know, a tweet can be a log. Obviously, a request to your web server can be a log. But it can also be this build has started, or this test has finished and it passed or failed. It can be this guy, this person committed. It could also be I opened a pull request. So depending on, you know, we've got some of the front enders really, really like Git flow. You know, it might be important to them how long their pull requests stay open. You know, how long has this feature branch existed for? Make sure they're not falling into traps. So a log in this sense can be almost any event that's occurred within your dev test, source control, build systems, anything like that. So we've got logs, we've got the data. One of the points of this when we set off was to try and reuse what we'd built in live for this. So that's a picture of one of the repurposed dashboards for what we call Badger. You can see no one's awake, we do some building and then we go away. Apparently we're quite constrained within work hours on that one. But it gives you kind of like how many commits, how many builds are kicking off. And also that's the second metric is the pipeline trigger lag. And then we've also been using Kibana 3 and 4 to visualize it in other more kind of ad hoc dashboard arrangements. One of the first dashboards we built in this kind of vein wasn't for devs or testers or anything like that, or ops. It was for the change management team. We just got a new release manager, and he was getting a bit bored of having to chase developers to find out, is this release kicked off? How far are you into it? Has it finished? And we're like, great, we've got the data. We can build you that dashboard. Just put it together. He was really pleased with it, and he could see exactly what was happening in live with the deploys. I suddenly realized that since it was being powered by the Go log data, we could actually use that as the build status monitor, which was looking quite dated. We were doing some profiling on the Go server itself and found that CC tray was actually taking up an inordinate amount of requests because we were pinging it from 19 different locations for every single build monitor in the room. Moving to a variation of the release screen meant that because it was more event-driven, that removed that load. And the teams really like it. They're used to editing it because it's the same tool that they've been building their dashboards for in live. And so there's no learning curve to it. So being able to use the tools there really helped as well. Alerts. One of the things I learned from production was dashboards are a bit like a drug. They seem like a really, really good idea, and it's really easy to get hooked on them. My CTO loved dashboards. He made me build dashboards for everything. It made sense to begin with. How much money are we making? How many requests are we making? How many requests on a browser are we making? How many requests are we making from browsers run by people with S in their surname who are hopping on one foot? And suddenly, you needed to look at all these dashboards to determine if something was wrong. So we had people sat there watching our dashboards, which really, really, really didn't seem like a very good idea. So we caught up very quickly, and we were using iSinger before. We moved to the latest version, which is really good. It's got a nice API, everything like that. If you've not encountered iSinger, it's like Nagios, but looks prettier. And we switched to that. And now we've got a set of alerts within our it's our production iSinger, but it's not really too much bother. It's not that much load. But it tells us if there's a problem with one of our development tools, we should jump on it. Because although it might not be a live production server that's down, it's something we need to deal with pretty immediately because we've got 9 teams worth of devs sat around not doing much. We don't wake people up for those alerts. Probably key to mention. Wouldn't be very popular if we did that. One of the other things that we discovered as we went through the production monitoring, and we've tried to apply here as well, is to be event-driven. So don't just have dashboards, don't just have alerts. I mean, alerts are part of it, isn't an event. But we've got a Slack channel everyone uses. Let's drive events into there. And everything's built around this extremely high-level architecture diagram that my excellent drawing skills have produced, this event stream. So this is very similar to what we have in live, just with slight variations. We have an event stream at the center of it, a bunch of different inputs from different sources, such as Go, the other CI systems I mentioned. We use 2 different types of ticket management systems for when one isn't enough. And they send their movements into there as well, so we can track those events. And also our source control system, so GitHub, GitLab, that kind of thing, all goes into a single event stream. That means that any application that connects to that event stream can get any kind of event and make decisions based on that. Then we have another type of application I class as consumers. They just sit there listening for events, and then they do some kind of, usually the input events are really, really raw, and they hammer it into some kind of sensible shape. So instead of a pipeline triggered in some capacity, it's this build started and it's within team mex. This test passed, this commit occurred, this build had this material, this ticket moved. It just kind of makes it a bit more domain specific as opposed to raw data. And those consumers can put that event back on the event stream so other people can listen to it. It can get emitted straight out into Slack via Hubot, and it can get stored. We keep state out the applications so that the alerting and the dashboards can show it as well. And you can refer back to the state if you need to. We called this project, when we built it, River Styx, because we have a really, really bad habit of misappropriating Greek mythology. We really did name a project Odyssey, and it really, really went that well. We chose some application types. RabbitMQ for the event stream, you could probably use Kafka or anything like that. We were comfortable with Rabbit, so we used it. Node.js, because I found it's quite easy to throw applications together quite quickly with that. Data store, so we could benefit from the dashboarding technology, and Docker containers, because they're really fun and new, but also it made it very easy to package applications and get them into a server dead quick. And that was kind of the key thing for all of this was the rapid development speed. The applications were designed to be as small as possible and only do one thing, kind of the Unix philosophy, rather than large monoliths that were trying to do all sorts of different things. The idea was that ultimately, in a way, when you're doing this kind of thing, there's a danger you're going to solidify your process, which you don't want to do. You have to be comfortable throwing these things away so that you can change your process when you need to, because you don't want these applications being a reason you can't change. So it really, whatever you can develop quickest, that's probably what you want to use. We're starting to open source some of the stuff we're doing. It's a bit of a slow process. There's some fairly heinous code that I need to remove before I can show it to normal people. But we're getting there. So once you've got all this data, you've got commits, ticket movements, all sorts of things. There's a distinct danger that it could all go a bit Orwellian. The key thing is that this data is for the teams. It's not for departmental managers to look over it and decide who's doing well and who's not doing well. It's meant to be for the teams to use in their own continuous improvement, to feed their own feedback cycles, to do their own improvement. Because you can't really compare teams. It's like comparing a small model of Thomas the Tank Engine and the Flying Scotsman, like comparing Newsnight and Game of Thrones, except those things probably have common themes. It's probably more like comparing apples and Diana Ross. There's just absolutely no way you can do it. The Team A, you can't compare to Team B. They're completely different entities. They might be using different measurements for their ticket sizes. They may be having completely different systems that they're having to maintain. So, if Team A has a cycle time of 4 and Team B has a cycle time of 15, well, a manager may infer from that Team B is really, really bad. But, they're having to deal with legacy code that Team A doesn't have to deal with. You have to take into context what the team's challenges are, which you can't do with pure numbers. So I would strongly keep this data for the teams and isolate it so that they can use it to drive their own improvement. So you've got metrics and events for the team. What kind of things could you do now that they do it? Well, now that you've got it. Data-driven retrospectives are really good as one of the types of format you can do. Postmortems, so hopefully everyone's comfortable with the idea of postmortems, blameless, the Etsy thing. It's all really good. Often I've used the live logs for providing context for that. So what happened at this time, mark it on a timeline, go through it, that sort of thing. What happens if we don't just use the live logs for that? What happens if we had log information from dev test? What happens if it was a test that went red, green, and we jumped on that, deployed it, in actual fact the green was a false positive? We probably should have listened to the first 5 reds. If we've got that log information and we can unify it with our production logs, then we can start to make those decisions a lot easier, those kind of epiphanies, those kind of ideas are a lot easier to discover. Automatic release notes, so if people are interested in what's being deployed when, potentially. If you've got all this information in the system, if you give it 2 commit references, you could find out what's in between if it's all in one system. Problem tests, so as I mentioned, if you've got flaky tests, it becomes a lot easier if you've got it in some in a kind of log format to identify which ones are the problems. And as coming back to the kind of the reason why I started doing this in late rooms, it's the justification for improving in pipelines and justification for investment. So if you're asking your PO or delivery manager, whoever is kind of saying this is what we're going to work towards next, saying we want to do some improvements to the pipeline. We know it's a bit flaky. We know it's a bit slow. We can deliver faster doing it. It's going to be a lot easier to get their buy-in if you can give them some kind of quantitative measurements. We spent 4 hours last week waiting on tests to go green because someone had to sit there pushing the rerun button. That's a lot easier than saying, Joe thinks the build's a bit slow. Can we have some time to fix it? And that, once the teams get together, if they can if they identify common themes in the data, they can make a wider effort to make some investment into the platform as a whole and say, actually, look, this is affecting all the teams in the department. Can we get some investment? It's not new features, but it will make you money by saving you money. Just touching again on data-driven retrospectives, they're really good. The Mad, Sad, Glad retro format, or a similar one, the really, really popular one. If you're doing that all the time, I'd strongly recommend looking at rotating your retro formats. And if you are going to do that, think about including data-driven retros in that. Even if you don't use all the data you can gather, even if you just use cumulative flow diagrams, or even your burn down if you're doing Scrum, that kind of thing. If you can make the data a talking point, then you can start to look into things a lot better than just generally, this is what we thought happened. If you've got a cumulative flow diagram, don't know who's encountered Kanban, but if it flattens, you're basically sat doing nothing. So if you can annotate that and say, well, what was happening around the bit where it flattened? If you've got log data that says, CI was having problems then, we had that flaky test around that point, you can start to annotate it and really drill into what happened a lot easier. Only thing to say is don't do it all the time. As I say, I'm a massive fan of rotating your retro formats, so just use it as one of your tools in your toolkit for bringing out, and this is kind of a good format to kind of splice in with the other ones. So what we do next? We're looking at more if this, dev that, if this, then do that. Kind of, at the moment, the applications are horribly boilerplate. There's so much, connect to Rabbit, do this if this event type, do that if that event type, push back into Rabbit. They're trying to split that off. But even then, it would be nice if you could just say, if this type of event comes through, cause this system, this action to occur in another system. Because there's lots of different dev-related tooling out there now, but they're not terribly well connected. So being able to do this kind of thing could make it so that you could actually have it so you have a truly event-driven workflow. Again, the kind of thing you don't want to solidify too much because you want your process to be changeable, but if you can do it lightweight using config, then it becomes a lot easier to do that. And then more inputs, better metadata. So kind of sum up, we had massive wins in production from doing logging. We try to apply that to our dev test environment to try and help us get investment to make it a lot less dodgy than it was. That's actually worked really well. We're setting up our new Go server today and tomorrow. I was hoping we'll switch over to that. It's got much better capacity. Unfortunately, had to scale vertically. I've been measuring this too, because I like measuring things. So hopefully all the tweets will have been positive. I've got sentiment analysis running over it, so I might be crying myself to sleep tonight. If you do want to see it, if you are interested in the data, give me a shout. I can't expose it because the Elasticsearch cluster is open to the world, and I've heard terrible things can happen if you do that, like zombies and the like. A slight shameless plug. I am involved in DevOps Manchester, at North. We are always looking for speakers, so if you're already up north, if you don't mind a train journey, it is actually terribly nice in Manchester, not at all like all the stereotypes. Come say hi. We'd be really, really interested in anyone who wants to come up north and share their stories or interesting things that they've got to say. Thanks for listening. Do we have time for questions? There's time for questions, and that link does not work. I just tried to use it. Don't use that. I will update it, and I will tweet it. And yeah, I'm on Twitter, and Late Research Engineers on Twitter. Thank you.
10 minutes for questions, if anyone has any. Awesome. For both talks.
Have any questions for both talks?
Oh, hi. When you're talking about your CD pipeline, how are you about doing CD of CD pipelines? How far along are you with that sort of thing? Or is it hand-rolled machines which are then kind of...
So, do you mean kind of like the testing of the automation and the building of the actual pipelines themselves?
Yeah, as in you go and say, okay, well, I have a CD tool set and I go and run various tests of that, and then of course I go and promote that actually to the live CD toolset.
It's not something we really consider at the moment. As I say, we've just come out of the stage where we've managed to justify this new server. So we're putting that in place. We're looking at a lot of automation just for the underlying kind of infrastructure for that. But we've not looked too much at kind of like testing the pipelines, if you will. It's mainly just putting the new system together.
Okay, thank you.
Told you it was a graveyard slot. All right.
Behind you, Anita.
Yeah. Okay. Around the way you changed the testing at the Guardian, has the skill set that you look for when you employ new people into your team changed? And if so, how? What do you look for now that you didn't look for then?
Yeah, it's changed massively. We basically look for people who are creative thinkers more than anything else. We look for we're mostly employing engineers, and we're mostly employing engineers who have a kind of like an esoteric bent, if you like. Because, you know, if people come into the team and you just say, oh, well, I don't know what quality is, you've got to go and figure it out and fix it, rather than saying somebody go and sit and write those tests. It's obviously somebody who's going to be thinking slightly differently about the product as a whole. So yeah, it's completely changed, and those people are almost impossible to find, actually. So if anybody wants a job and they fit those criteria, then yeah, we're still hiring. So.
So I'd really like to know what that single test is that you run against. Is it a test that tests like everything, or is it a test that just tests are you up, or is it some kind of golden path use
Yeah,
case?
no, it's just can you sign in and make a purchase? That's it. So it's testing two things: sign in and making a purchase, actually. But yeah, just one test.
So around the Guardian there, if you have a third-party team in a room and a year later you find out what they're doing isn't really fit for purpose, that seems more like a sort of waterfall organizational kind of failure. I mean, wouldn't you want to be more agile and, like, after a month or so try and pivot to something more monitoring-based?
Well, we were doing that as well, I guess. I mean, that was the thing. We kind of that we had. That was what we had. It wasn't all a third-party team. It was one third-party person and two people from the test team. So, and they were kind of. This was 4 years ago, I guess. So, you know, kind of the art of writing automated kind of end-to-end regression was kind of fairly, you know, underdeveloped. So, we did have kind of the development team over here were working on kind of other bits of tooling and monitoring and stuff. But we did come to a point where all of those things were being more successful, the monitoring and the alerting and the deployment and the decoupling of tools, where we just, you know, we did literally just suddenly have a eureka moment and go, actually, we don't, this stuff, A, doesn't work, and B, we don't need it. But it was more kind of, we don't need it rather than that it doesn't work. They both kind of happened at the same time. So, and we really didn't need it. It was like, if you can fix things quickly, why do you need to write the tests?
I'm interested to find out if your metrics on your dev test actually came up with any surprises.
Well, as Jess said, confirmation bias. The key thing that it actually, so as I say, one of the chief hypotheses before we started was that there was a big lag between when a commit got triggered and when Go picked up on that. We haven't actually managed to see that particularly well. It's actually a very consistent metric, as it didn't show very well in the graph, but it's actually sitting at about 2 minutes near constantly, which I was actually hoping it wouldn't, so that we could. There were other things that helped elsewhere. We did prove that the agents weren't a particularly useful resource, and they were a bit all over the place. So it was more the other metrics we were tracking, the flaky tests, that kind of thing. One of the core metrics that we thought was going to be important, git commit time, didn't really pan out.
Cool.
That was probably our chief surprise.
Nice. Thanks.
Just interested to know how big your team is that supports your CI tooling.
So we are officially, as I say, we're part of, we call the IO team, which is Infrastructure Operations, not Input Output, it's a really bad name. We've got several disciplines within it. So there's your traditional sysadmins who primarily keep track of the live estate, keeping servers up and running, that kind of more traditional element to it. And then we've got some developers like myself, and there's 3 of us. We tend to be more slanted towards the CI systems because we've got more experience in that area, but thankfully there's a lot of crossover, which is why we have the team in the first place. I'm totally a Windows boy, and I've been learning about Linux, and they've been learning more about coding, and that kind of transfer of knowledge has been really good. So primarily in our team of about 9, there's about 3 of us who manage the CI system, and there's about 1 or 2 people elsewhere in the department who we kind of heavily rely on to help us out in times of need.
So is it a team that reports into your IT development or your IT production area, would you say more? Or do you have that kind of like distinction between them?
No, we do. So there's head of delivery who's in top of all delivery teams. So we are roughly in product teams, of which all report to the delivery manager. And then the head of our team, he reports in at the same level as he does. So there is a split, but because we've got so many either developers or ex-developers in it, we talk so much that it isn't really there.
Thank you.
Oh, well,
So
there's one more
over
this time, I don't know.
Hi. So 343 ways in a day. Do you track how many of those are bug fixes and where that trend is going?
Sorry, can you ask again?
So 343 deploys a day. Do you track how many of those are bug fixes and how many, what the trend is?
No.
Follow-up question, how do you track quality?
Yeah, that's a very, very, very good question. And that's kind of, what I think the first question is, how do you define quality? And that's the key, because it could mean different things in completely different teams. So in our editorial tools team, how do you define what quality is when you have a captive audience and they all have to use the tool, right? So we were thinking of having a swear button on the tool. It's kind of a web tool, so you having a swear button so that if something went wrong, the editorial staff could kind of bang the swear button, and then we were going to kind of log how many times the swear button got pressed the day, see if that declined. You know, you could measure kind of downtime, but that kind of makes no sense if you don't do any deploys for a month. Then downtime and kind of breaking changes aren't meaningful. So star ratings in our iOS app are a kind of big thing, on our Android app. So you can measure that, but we're kind of at the mercy of kind of third-party kind of advertising as well. So user engagement, how many user feedback do we get a month? It could be, it's a kind of a smorgasbord of different measures basically, and that's kind of key to what we're going to be doing in the next year. Kind of firstly defining and then measuring. So it's a big question, I think.
So,
That's it.
Sorry.
Sorry.